We have come a long way since the first stone tools were fashioned by our hominid ancestors. Today, we stand on the brink of achieving technological feats that once seemed the stuff of science fiction. Quantum computing, a field of study that seeks to develop computer technology based on the principles of quantum theory, promises to revolutionize our world. AI, our own creation, is becoming more intelligent, more capable, and more pervasive in our lives.
In fact, I think the synergy between biotechnology and artificial intelligence is going to revolutionize everything around us.
The deliberate collision of two game-changing technologies has the potential to upend the technology industry and bring about a new era of business disruption and innovation. Few industries will be spared this transformation, and it will create completely new value and risks. Hyperbole? I don't think so. In the future, artificial intelligence is likely to become supercharged by quantum computing. It, as renowned theoretical physicist Michio Kaku said, is a partnership that could change the world.
Everything is going to be affected when we can multiply the power of a digital computer by a factor of millions to billions. So we're talking about a new era in computation that'll change everything.
The growing wonder and value of artificial intelligence, or AI, triggered by the broad availability of generative AI in late 2022, is understandable. Uses of this software, such as the creation of remarkable human-like text and graphics, can often exceed the hype. That's saying something for the technology industry that too often gets ahead of itself. Frequent and mesmerizing new updates to generative AI and the innovation that quickly follows demonstrates that this technology is evolving at breakneck speed. But despite the introduction of faster microchips to feed its hunger, AI is ultimately constrained by our ability to continue to squeeze more processing power from silicon-based hardware. It's just a limitation of physics. That said, let's recognize that classical computing, based on transistors and electricity, has served us all well and powered the information age to date. If AI could be powered by a new generation of computing power, quantum processing, then it would leave today's innovation in the dust. That day may be coming sooner than you think. It may not be next year, but could we see practical applications within the next decade? Quantum computing, an entirely new way of processing information, when combined with AI, has the potential, without exaggeration, to bring about a new computing revolution. Transformation may be an understatement. Today, quantum computing isn't a term that's particularly familiar to those outside the technology and physics worlds, but it soon will be. This form of computing, still in its relative infancy, originates out of quantum mechanics, the behavior of nature at the scale of atoms and subatomic particles. Leveraging this science to power, a new form of computing began in earnest in the 1970s. By the 1980s, notable scientists such as Paul Benioff, Yuri Manin, Richard Feynman, and David Deutsch established the core principles. By the late 1990s, the first functioning quantum computers emerged. Instead of processing information in terms of ones and zeros, called bits, and doing it serially, which is how classical computing works, quantum computers use qubits, which can represent a 1 and a 0 simultaneously. Like a guitar, bits are similar to playing one note at a time, whereas qubits play several notes together. With enough qubits, quantum computers could theoretically be millions of times faster than the fastest microchip computers today. To give a sense of how fast that scales, in 2019, Google reported that its 53-qubit Sycamore computer could solve in 200 seconds a mathematical problem that would take the fastest digital computer 10,000 years to finish. In 2022, IBM unveiled a 433-qubit quantum computer. The 1,121-qubit follow-up is due any day, and it hopes to have a 4,000-qubit version, working by 2025. So it could be said that the field is moving fast.
It's only a matter of time before we leave the digital era and enter the next era, the quantum era, when we compute on atoms. Now, it's not easy to compute on atoms, but that's the future. That's the way Mother Nature does it. And you have to have quantum computers to understand the quantum laws of life.
Big tech firms such as IBM, Microsoft, and Google, and many compelling market entrants such as IonQ and D-Wave Systems, have been making significant strides in exploring the possibilities of this cutting-edge technology. Quantum supremacy, the point at which a quantum computer kicks a digital computer's ass, is in the rear-view mirror. The only problem is that for quantum computers to work, so far, they need to be cooled to very near absolute zero. As Michio Kaku explains, you have to cool it down to where all the extraneous vibrations and noise are eliminated. Somebody's burping, somebody's jumping up and down, a car backfiring a block away would ruin a quantum calculation. A whole range of different approaches are even now competing worldwide to get the edge on making bigger quantum computers faster. However, when they get there, they will transform everything. Digital computers simply don't have the capacity to model chemical reactions at the molecular level. Quantum computers will. According to Kaku, chemical reactions are mediated by electrons. Electrons are described by waves. Waves are probability. Where are the zeros and ones? Nowhere to be seen. A 0 and a 1 is an approximation, a crude approximation, to a wave. And that wave is the wave of an electron. Why is that important? Because that electron gives you cancer, gives you well-being, gives you solar energy, gives you fusion power. Mother Nature is quantum mechanical. The universe is in some sense a quantum computer. That means quantum computers will allow us to do chemistry without chemicals. Everything from batteries to vaccines is currently invented effectively by trial and error. But if you can accurately simulate chemical reactions, you don't need bubbling flasks. The secrets of everything from human aging to photosynthesis can be unlocked. In other words, quantum computers are going to be the solution to all mankind's problems. And that shift from the digital to the quantum age will be a greater leap than the original digital revolution. As Michio Kaku wrote on his book, Quantum Supremacy, how quantum computers will change everything about the economy, medicine, warfare, everything is going to be turned upside down. For now, there's a lot of optimism that the pace of quantum computing innovation will continue to accelerate, and we could see mainstream adoption by the end of the decade. That's just around the corner. Independent of artificial intelligence, quantum computing is going to be a big deal. However, coupled with AI, it will be a game changer.
We're now at the initial stages of the next revolution.
Revolutionary innovation is not an exaggeration. In the interim, work to integrate artificial intelligence with quantum computing will continue. Research is nascent, and non-trivial technological hurdles exist. Quantum artificial intelligence, or quantum AI, and in particular its subset research area quantum machine learning, will use new quantum-designed algorithms with superpowers that result in much more powerful AI models. As quantum AI gradually emerges, we can expect significant improvements in the speed, efficiency, and accuracy of AI. We should also anticipate the emergence of completely new and surprising business capabilities. At first, the benefits will be reaped by certain industries and needs, particularly those with optimization requirements. But later, as quantum AI becomes more mainstream, the thrilling connections that bind quantum computing and AI will pave the way for a new era of innovation. As such, almost every enterprise will need to have a strategy. Quantum AI brings a paradigm shift to traditional computing, promising unprecedented computational speed and efficiency. Quantum computers excel at solving optimization problems, a task that has vast applications in AI. The parallel nature of quantum computation allows for quicker processing of vast datasets, significantly accelerating machine learning algorithms. The synergy lies in the fact that quantum AI can complement classical AI algorithms, enhancing their performance and tackling problems that were once considered intractable. As we delve deeper into the capabilities of quantum AI, it becomes evident that this fusion has the potential to reshape industries and solve real-world problems.
Quantum computers will change everything. The economy, how we solve problems, the way we interact with the universe. You name it, quantum computers will be there.
One of the most significant advantages of quantum AI is its prowess in solving optimization problems. Many real-world issues, from supply chain management to financial portfolio optimization, involve finding the best solution from a vast number of possibilities. Quantum computers, with their ability to explore multiple solutions simultaneously, excel in addressing these optimization challenges, providing solutions in a fraction of the time it would take classical computers. In addition, AI algorithms, particularly machine learning models, often demand immense computational resources. Quantum AI can expedite the training and inference processes, allowing for the development of more sophisticated models and pushing the boundaries of what AI can achieve. This acceleration is particularly crucial in fields like healthcare, where rapid analysis of medical data can lead to quicker diagnoses and improved patient outcomes. Quantum AI is not only about speed, it also introduces a new paradigm in data security. Quantum key distribution leverages the principles of quantum mechanics to secure communication channels, making it theoretically impossible to intercept messages without detection. As AI systems become more integrated into critical infrastructure, ensuring robust cybersecurity measures becomes paramount. While the potential of quantum AI is exciting, it is essential to acknowledge the challenges and limitations. Quantum computers are notoriously delicate, requiring extremely low temperatures to operate. Moreover, the field is still in its infancy, with many technical hurdles to overcome before achieving widespread practicality. Additionally, the integration of quantum AI with existing systems poses compatibility challenges that need to be addressed. Despite the challenges, the future of quantum AI appears promising. As research and development progress, we can expect more stable and scalable quantum computing systems. The integration of quantum AI into mainstream applications will unlock new possibilities, paving the way for advancements in drug discovery, financial modeling, and climate simulations. In conclusion, quantum AI represents a thrilling frontier in the world of technology. The fusion of quantum computing and artificial intelligence opens doors to unprecedented computational power, with the potential to solve complex problems at a pace previously unimaginable. As industries and researchers continue to invest in this cutting-edge field, quantum AI may well be the key to unlocking the next era of innovation. The journey ahead is challenging, but the rewards in terms of technological breakthroughs and societal advancements are too compelling to ignore. In the coming years, quantum AI will likely be at the forefront of scientific and technological advancements, driving innovation across diverse sectors. As we embrace this exciting future, the synergy between quantum computing and AI will undoubtedly shape the digital landscape, creating new possibilities and transforming the way we approach complex problem-solving. Thus, rather than playing catch-up when quantum AI arrives, organizations should have the technology on their radar and follow developments closely. Those lucky enough to have an innovation lab or equivalent should consider some experimental and research work, if only for the purposes of acquiring skills and knowledge. The high level of interest from industry and the pace of scientific research clearly suggests that quantum AI is coming, and the question will be whether you are ready.
All the big players are part of this race because if they're not, Silicon Valley could become the next Rust Belt.
It's probably closer than you think, and it's likely going to be a very big deal. Because even leaving aside the control problem, when quantum computers give the development of AI a hyperspeed boost, the first thing that they'll do along the way is to make it possible to break by brute force. That is sheer computational every form of encryption on the planet. So potentially, goodbye to all military and civilian secrets. not to mention the secure transactions on which the entire global financial system depends. And with world powers competing to get first-mover advantage in the quantum computing realm, that gives the phrase quantum supremacy a geopolitical shading. So what branch of the government is most interested in advancements in this technology? It's the CIA.
These quantum computers can crack any known digital code. So this means the crown jewels of any nation, with all their top secrets about the military and defense posture, all of that can be broken into by an advanced quantum computer.
Government agencies are already beginning to issue statements saying, be prepared, start to make changes now in your behavior, because when this revolution is in full blast, it means that all your secrets can be read by your next-door neighbor. We're not at the point where we have to worry about this technology every day, but it's coming. The likely defense against this sort of disaster, as Kaku says, is use quantum to defeat quantum. Another idea is to have a dual internet. One internet that can never be broken because it's all based on laser beams and the quantum principle, and the other one we use, you and me, that can be broken if you have a powerful enough quantum computer. A laser internet could use quantum principles to incorporate tripwires. Laser beams are polarized, meaning they vibrate in only one plane, and that plane changes when they are interfered with. By looking at the change in the direction of the polarization, immediately you know that somebody is trying to hack into your system, and then you can take safeguards to kick them out. We're talking about 10-15 years in the future when quantum computers are so powerful, they can break any code. And then, of course, the CIA has a nervous breakdown trying to figure out all the different ways we can use the quantum principle to defeat the quantum principle. So, cross that bridge when we come to it. Currently, researchers have been working to develop public key algorithms that could resist code-breaking efforts from quantum computers, preserving or restoring trust in certificate authorities, digital signatures, and encrypted messages. Notably, the U.S. National Institute of Standards and Technology is already evaluating 69 potential new methods for what it calls post-quantum cryptography. The organization expects to have a draft standard by 2024, if not before, which would then be added to web browsers and other internet applications and systems. In principle, symmetric cryptography can be used for key exchange. But this approach depends on the security of trusted third parties to protect secret keys, and it cannot implement digital signatures, so it would be difficult to apply across the internet. Still, it is used throughout the global system for mobile communication cellular standard for encryption and authentication. Another alternative to public key cryptography for key exchange is quantum key distribution. Here, quantum methods are used by the sender and receiver to establish a symmetric key, but these methods require special hardware. Strong cryptography is vital to overall individual and societal cybersecurity. It provides the foundation for secure transmission and data storage, and for authenticating trusted connections between people and systems. But cryptography is just one piece of a much larger pie. Using the best encryption won't stop a person from clicking on a misleading link or opening a malicious file attached to an email. Encryption also can't defend against the inevitable software flaws or insiders who misuse their access to data. Even if the math were unbreakable, there can be weaknesses in how cryptography is used. Microsoft, for example, recently identified 2 apps that unintentionally revealed their private encryption keys to the public, rendering their communications insecure. In short, if or when powerful quantum computing arrives, it poses a large security threat. Because the process of adopting new standards can take years, it is wise to begin planning for quantum-resistant cryptography now. However, as we stand amidst this technological revolution, we are compelled to ask, why are we evolving like this? Are these advancements making our lives easier? Undoubtedly, yes. But does easier equate to happier? Is the pursuit of convenience and efficiency the ultimate goal of our existence? Or is there something more, something deeper, that we should strive for? As we ponder these questions, let us take a moment to marvel at the grandeur of the universe. This magnificent cosmos, with its galaxies, stars, and endless mysteries, evokes a sense of awe and wonder. Is it not extraordinary that in this vast universe, we, as a species, have the capacity to question, to understand, to invent, and to explore? Maybe. After all, the beauty of human evolution lies not merely in the creation of advanced technologies, but in our persistent quest to understand our place in the grand cosmic theater. The universe did not come into existence by chance. It is the product of precise laws and principles that govern its functioning. Similarly, our advancements in technology, such as AI and quantum computing, did not just happen. They are the result of the relentless efforts, curiosity, and intelligence of humans. In this context, how can we believe that the universe, in all its complexity and beauty, came about by mere chance? It is a testament to a greater force, a divine architect, God. Accepting the greatness of God is not a sign of surrender, but an acknowledgement of the beauty and complexity of the universe. It is a key to true happiness, a happiness that arises from understanding our place in the universe and humbly acknowledging the mysteries we are yet to unravel. As we marvel at the universe and our place in it, we must also question our relentless pursuit of technological advancement. Is our ultimate goal merely to create machines that mimic human intelligence? Or should we aim for something more profound? Our quest should not just be about making life easier, but about enriching it. Technology can and should be a tool to elevate our understanding of the universe, to help us unravel its mysteries, and ultimately, to help us understand ourselves better. We must remember that even as we strive to unravel the secrets of the universe, the journey is as important as the destination. The quest for knowledge, the thrill of discovery, and the joy of understanding are what truly make us human. These are the things that make life worth living. In conclusion, as we continue our evolutionary journey, let us remain humbled by the grandeur of the universe and strive to understand our place in it. Let us use our technological prowess not just to make life easier, but to enrich it, to enhance our understanding of the universe and ourselves. After all, isn't that the noblest pursuit? In the grand theater of the cosmos, humanity stands as a testament to the power of evolution and the potential for intelligent life. Our existence is a delicate balance, a product of countless variables coalescing into a symphony of life. As we delve deeper into the mysteries of our universe and ourselves, profound questions arise. Why is there something rather than nothing? Why do we exist? Why does time only move forward? Why are we both good and evil? Why is the universe just right for life? Why are we conscious? These are just a few of the contemplations that science seeks to answer, a testament to our inherent curiosity and drive for understanding. As we explore these questions, we're also shaping our world with the tools of our own creation. Quantum computing and AI stand at the forefront of these tools, promising to revolutionize our understanding and capabilities. Quantum computers, predicated on the principles of quantum mechanics, have the potential to perform complex calculations much faster than classical computers, opening up new possibilities in fields like cybersecurity, bioengineering, AI, finance, and complex manufacturing. In tandem with quantum computing, AI has seen enormous strides, transforming our lives in various ways. From automated medical diagnoses and autonomous driving to movie recommendations and voice assistants, AI's footprint is growing. It's assisting us in drug discovery, decision-making, and providing basic assistance, such as text-to-speech for the visually impaired. Yet, as we increasingly rely on AI, it's imperative that we ensure their ethical use and accountability. As we revel in our technological advancements, we must not forget our ultimate quest, the pursuit of meaning and happiness. The progression of technology is not an end in itself, but a means to enrich human life. We evolve and innovate not merely to make life easier, but to enhance our understanding, to foster our connection to the world, and to create a more compassionate society. Contemplating the magnificence of the universe, one cannot help but marvel at its intricacy and beauty. The grandeur of the cosmos, the enigma of life, and our own existence are not products of mere chance. They are the results of billions of years of evolution, of cosmic laws working in harmony, and of our own relentless quest for knowledge. As we journey through this vast cosmic ocean, let us remember that our ultimate goal is not merely to survive, but to thrive with passion, compassion, humor, and style. We may not find all the answers, but the quest for understanding, the pursuit of knowledge, and the appreciation of beauty around us are what truly enrich our lives. The key to happiness lies not just in understanding the world around us, but also in understanding and accepting ourselves. Indeed, our journey is far from over. With every step, we unravel a little more of the cosmos and ourselves. But in this relentless pursuit of knowledge, let's not forget to pause, to marvel at the universe around us, and to appreciate the beauty of the journey itself. As we evolve and discover, let us remember, in the grand scheme of the cosmos, we are but a fleeting moment. Yet, it's in this fleeting moment that we find our purpose, our joy, and our place in the universe. That's all the information that we have for you today. Don't forget to give us a thumbs up if you enjoyed today's episode, subscribe if you haven't already, and hit the bell so you never miss out on future episodes. And be sure to also tell us what you think about today's content. Everyone's support motivates us to continue delivering quality content and to always improve. As always, thanks for watching, and we will see you next time.